Okay, we're here today to demonstrate the use of the SimpleCount Sperm Kit. We're going to do the first presentation or demonstration using raw semen, fresh collected semen, to calculate the concentration so that we know how many doses to make out of an ejaculate. The pieces involved in the kit are a pipette such as this one, pipette tips such as these, a very specialized glass slide, disposable glass slide with a fixed cover slip and a counting grid, a microscope. We happen to be using one today with an attached camera hooked up to a monitor, which makes the process much easier. And then we're also using a slide warmer, which can be replaced with an electric heating pad or even a non-electric heating pad. Just something to be able to bring the slide and the sample to body temperature. The first thing we need to do is to prepare a dilution of the semen with extender. And what we want is a 10-to-1 dilution. So what I have in this tube is semen extender, and we have our pipette at 200 microliters, and we're going to put 10 pipettefuls into this empty tube to have a 10-to-1 ratio. So we start, that's 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Dispose of that tip. I'm going to grab a fresh tip here. Now we have our raw semen that was just collected. We need to get a weight of the semen. So we have 315 grams of semen. We need to stir the sample good so that because sperm cells settle very rapidly, we need to get a good homogenized sample. So we're going to pull a sample of crude semen and add that. Put the cap on, and we want to stir it very good so that we get a good mixed sample shortly before we draw our sample to load the cell vision slide. So now with a fresh tip on the pipette, we draw a sample and we load both chambers of the cell vision slide. If we can get a close-up of the loading of the chambers, all we have to do is put a drop in the entryway, and the chamber loads by capillary action. Okay, we load both chambers. Okay, and then we wipe the excess from the loading end to avoid getting the wave action when we put it on the microscope. So now we'll put this on the microscope. Oops, I need to move this. So as you can see on the screen, what we have at the very front section of the cell vision slide, we're able to view the motility of the sperm. And we can move this around and get various fields of view. And we can see that this semen has very good motility. There are a few non-moving cells, but overall this is probably an 85 to 95% sample. So very good, very usable semen here. Good forward progressive motility. So the very front of the cell vision chamber can be used to analyze motility because the semen is not fixed, it's moving very well. Now, the important part is to calculate our concentration. So we're going to move the field of view to where the grid lines are on the cell vision slide. And you can see that as I get to this part of the slide, the sperm cells aren't moving. Now we can begin to see the grid lines, or they're moving but very little. So what we want to get in focus are the squares. These squares are in rows of 10 and columns of 10, so 10 by 10. And we need to count all of the sperm cell heads that are within 10 consecutive squares. And we can pick any row or any column, and we want to read 2 rows or 2 columns or even 10 diagonally in either direction to calculate the concentration of the ejaculate. Now, as you can see, some cells are still moving, but they're not moving significantly. If you have too much motion, you can eliminate that by heating the sample to about 40 or 50 degrees centigrade for generally less than a minute, and that will stop the motility almost completely and make it easier to count. I'm going to do that right now so that we can get a little bit better count on this sample. So we're going to place this on the slide warmer, turn the temperature up, and heat that sample just a little bit longer so that we can get a better analysis. Okay, that might be enough to do the trick. Oops. Okay, so we've still got a couple of swimmers, but not too much. Now, when we count, we want to count the number of sperm heads that are within the square, and we'll count the sperm heads that are touching the line only on the top and the left side of the square. So we don't count every sperm cell that's touching all the way around, only the ones that are either within the grid or on the top and left side. So in this case, we're going to count across. I can do this probably with the pointer on the mouse. Here we have, in this square, we have 1, 2. In this one we have 1, 2. In this one, if I focus, we have none. We have a little bit of foreign matter. So far we're at 4. I'm going to move to the next field of view. Here we have 1, 2. Here we have 1, 2. So now we're at 6. Here we have 1. We're at 7. Here we have 1, 2. We're at 8. Okay, and we have 3 more squares left to read. This one has 4, so that puts us to 12. This one has none. This one has none. So we have 12 cells in a row of 10, which gives us 12 million sperm cells per milliliter of semen. Now, we diluted the sample 10 to 1 in order to have it thin enough to be able to count. So we have to multiply that factor back in, which means we have 120 million cells per milliliter. If we multiply that times the volume of the ejaculate, which was 315, find a calculator. we have 315 times 120 million, or 37.8 billion sperm cells. If we want 3 billion sperm cells in a dose of semen, we divide by 3 billion, we can make 12.6 doses of semen. So that's it in a nutshell. Now, to be accurate, we want to count 2 rows in this chamber, and we also loaded the second chamber on the slide, which is now in focus. And so we want to count 2 rows in that chamber, and then we take the average count of all 4 rows to get a more accurate concentration. That's how you calculate concentration of raw semen using the SimpleCount Sperm Kit.